start. Hello and welcome back to Calculus 3 section 13.4 on the cross product. Cross product is yet another way to multiply two vectors, but this time your result is going to be a vector, not a scalar as it was in the dot product. So the cross product of two vectors produces a new vector. That vector, we are going to write the theorem for this, that vector will be perpendicular orthogonal to the other two vectors. And the cross product will have a little bit annoying way to compute, but when you get used to it, it will speed up. Another very important aspect of the cross product is that it's available only in certain dimensions. We in this course are only considering 3D, so it's available for 3D, and we are going to have the 3D. But there are other dimensions like 7 dimension, 11, and so on. So there are certain dimensional spaces that have cross products, and then other dimensions do not have a cross product defined. Cross product cannot be defined for 2D space. So the entire lecture over here is R3. So I'm going to write first over in blood R3 only. Now I did tell you there are other higher dimensions that have their cross products as well. So this is not exclusive to R3, but when I write R3 only, that just primarily means no R2. So what is the definition for the cross product? Definition for the cross product will be that the magnitude of U cross V is going to be magnitude of U, magnitude of V, sine theta. So magnitude of U, magnitude of V, sine theta. From here, you can get an equation that calculates angle between U and V, which is the one formula you never want to use because you have to compute the cross product, right? You have the one with the dot product, which is a joke to compute. So I'm still going to write this as the inverse sine of absolute U cross V divided by magnitude of U times V. As the angle between vectors U and V, we do not want to use this. So I'm just going to say in parentheses, use the dot product instead. Use the dot product. Because dot product formula is much faster. So now we're going to take a look at what it takes to compute the cross product. So if I have U cross V, and this has to be in R3, that means that I will be crossing U1, U2, U3 with V1, V2, V3. So this is what I have. And the way it's computed is we are calculating the determinant of the 3 by 3 matrix. You have your I, J, and K on the top row. The second row is U1, U2, U3, and then V1, V2, V3 on the third row. Now, you can catch up writing later. Please look at the screen to see the pattern, to break this into a 3 2x2 systems and then solve those. And then you can catch up with writing. So this is how it goes, guys. You start by placing I first. Just look at it. And now when you place I, that will eliminate row and a column. So the matrix, 2 by 2 matrix that you need to consider is going to be U2, U3, V2, V3. And you are done with I's. Then you will put negative J. If you're interested why is negative, take linear algebra. And that will eliminate row and column. And you are left with U1, U3, V1, V3. And you are done with J's. Finally, plus K hat will eliminate row and column where K is. And the leftover matrix is U1, U2, V1, V2. And then you need to solve each one of these. Now these are solved by placing, you can use this symbol like that, because, so I open parenthesis, you will multiply U2, V3, and then subtract V2, U3. So you go down, you enter this way, you exit that way, and you can see that it's U, in the middle it looks like a cross, like a multiplication. So U2 times V3, over here is flat, so it's like a minus, and then you have your V2, U3. So just by placing this symbol through, you quickly come up with what you are supposed to calculate. So next one is minus J. You go with the same symbol, so U1, V3, minus V1, U3, and finally plus K, which would be U1, V2, minus V1, U2. I have seen students memorizing the last two, right? Memorizing this thing, and then getting one of these wrong, and then just the whole thing goes to hell. But then I also see students who do this. I'm working with I, they just cover it, and they go, whoop. I'm working with J, whoop. So all of this stuff is, coded in there. You know that meme that has like a small brain and then it lights up low and then supernova brain? Yeah. So the first level is this one, memorizing this. Okay. From there you go. So supernova is the one that just goes matrix and then the answer over here, because when you cover this, you just multiply and subtract and write a number. You cover this, multiply, subtract, and you write a number. It goes like that. But, again, it takes practice to get there. So please, do your, right. So, let's take a look at the problem. Let's say you want to cross 1, negative 3, 6 with 4, 2, and negative 5, whatever. Evan, don't forget the charger.
Yeah, no, not good.
Oh yeah, okay. So we will put ijk 1, negative 3, 6, 4, 2, negative 5, and then have I, negative 3, 6, 2, negative 5, negative J, which is 1, 6, 4, negative 5, and then plus K. So these are all I hat, J hat, K hat. 1, negative 3, and 4, 2. Cool? The next one is I hat, and now we're computing. 3 times negative 5 is negative 3 times negative 5 is positive 15 minus 12 minus j hat, which is negative 5 minus 6 times 4 is 24, plus k hat of 2 plus 12, because it is 2 minus negative 12, right? So it's going to be 2 plus 12. Now you can just put the spiky brackets and write 15 minus 12 is 2. It's 3. Sorry, 15 minus 12 is 3. Now you have negative 29, and the negative in front is positive 29, and you have 14, and you close the spiky bracket, because the answer is a vector. So what you have in this case is you have 2 vectors in a plane, and you have a third vector. So if this is your vector u, and this is your vector v, this vector over here is u cross v. So this is what we have for our. Now this vector is perpendicular, or if you want to say orthogonal, to both of your input vectors. Your vectors u and vectors v, right, both of those vectors are sitting on the floor of this classroom, let's say, and they will multiply into a vector that is perpendicular. So I'm orthogonal, right, to the surface of the floor. So there are 2 vectors in the plane that, when multiplied, will give you the vector corresponding to my height. So cross product calculation is this long procedure where you break 3 by 3 into 3 2 by 2s, and then determinant of each 2 by 2 is calculated by taking the difference of diagonals. Right, so you multiply minus, you multiply the other way, multiply minus, multiply, multiply minus, multiply. Grade pitfall is right here. For whatever reason, you forget the negative in front of j. So make sure you have positive I, negative j, positive k. One more time. Positive I, negative j, positive k. So now we know the cross product gives us perpendicular orthogonal vector to the surface, and we also know that it will we can use it to calculate in very inefficient way angle between vectors u and v. Now cross product can also be used to quickly tell us if the lines that we are considering are parallel, vectors that we are considering are parallel. Because if you take a look at the definition, it contains sine of the angle between vectors u and v. So if you have, so this is now new concept, if you have vector u and vector v parallel like this, then the cross product between them is 0, because 2 vectors are parallel. In this case, the angle between those 2 vectors is 0. Right? Vectors are free to move in space. When you take that u vector and you put it on top of the v vector, it will end sooner than v. So it's not the same vector because their magnitudes are different, but they have the same direction. Therefore, the angle between them is 0. Sine of 0 is 0, and we see that parallel vectors and the angle between them, right, was 0. Now, this also means that if you have the opposite vectors like this, right, so these are now completely different because they're orientation is different and their magnitude is different. So in this case, theta is 0 degrees, and in this case, theta is 180 degrees. Well, sine of 0 degrees is 0, and sine of 180 degrees is also 0. Therefore, you can see that cross product can detect parallel vectors. So we can write one of those cute theorems with if and only if. We say vectors u and v are parallel if and only if, right? This is the one that goes back and forth. If and only if the magnitude of u cross v is equal to 0. We have to use magnitude of u cross v because u cross v is going to be a vector, right? And we can't say vector is equal to 0. You cannot set a third-dimensional vector equal to 0. You can set the magnitude of the third-dimensional vector equal to 0. Remember that the answer, right? The answer for the cross product is always a third-dimensional vector. So you cannot say that this is equal to 0. That makes no sense. Dimensionally or in whatever way, makes no sense. You can set a third-dimensional vector equal to 7 or 0. But you can say the magnitude of this, and then you will get some kind of number, right? When you add all of the components. I mean, Euclidean distance. So we have this cute theorem. It might pop up once or twice here and there. It's cute. Probably you're going to use it for some of your calculations to speed up some of the calculations if you want it. Now we have the properties. Of cross product. Okay. We have the anti-commutative property. So far we only had commutative property. Anti-commutative property means that it's almost commutative, but it's not. So property number one is that u cross v is equal to the negative v cross u. It's close, but it's not the same. So we call it anti-commutative. And then we have associative distributive, and we're done. So 2 AU cross BV. A and B are obviously constants because U and V are vectors. Is AB U cross V. Number 3, distributive property of vector U cross V plus W is U cross V plus U cross W. And another distributive property of U plus V cross W is going to be U cross W plus V cross W. Now you might be wondering why you have number 4, which pretty much is the same as number 3. Well, it's not, because remember, it's not commutative, so you cannot assume that swapping these two will give you the same result. They have some cool exercises for you to practice if you want to. They want you to show the cross product calculation where you say I cross J gives you K, and then they want a proof. Proof for this. Oops. And where you get the proof, obviously, is you just put 1, 0, 0, 0, 1, 0, and when you crank the cross product, you will get 0, 0, 1. So you can do that calculation if you're interested. It's very quick. So I'll write this in blood. The most important aspect of cross product is the fact that it creates an orthogonal vector to the plane containing vectors u and v. So the most important aspect of the cross product is that it gives you that vector. We are going to learn equation of the plane. What is a plane? Surface of your notebook, surface of the board, surface of the desk, the floor, the wall. All of those are planes. And the planes in space can be angled. If you look at the screen of my tablet, it's angled, right? So it's a plane, it's a flat surface on which I can write, and I can get it at the different angles, right? And then there is this kickstand in the back that also takes different angles. So the entire equation of the plane, which contains x's and y's and z's, it's coming up in a course, obviously. The entire plane can be described by a single vector. It would be a normal vector. And that normal vector will be computed through the cross product. It's insanely important, right? So why is it important? Guys, calculus is a study of change. In Calculus 1, you learn that the change is computed through the derivative, and the derivative was the slope of the tangent line. Calculus 3 will be computing tangent plane. And the normal vector for the tangent plane will be the cross product of two vectors. So, one of the most important aspects of calculus for Calc 3, right, is the cross product, which will create a normal vector that describes a plane. So, that's the most important part. Now, to end this lesson, we are going to take a look at the application of the cross product, and we can talk about the torque. There are other applications. We'll see the tangent plane and all of that other stuff pertaining to math later on. Right now, some physics, because it's awesome. So torque is the force that works in a circle. What is it? Well, when you twist the screw, right, the wrench, when you open the door, the torque is applied. You apply the torque in a linear fashion, but you apply the force in a linear fashion, but the motion of the force is twisted. So when you have, let's say you have a bolt, and then you have a wrench around it, so this is your bolt right here. You will apply the force here, and as you can see, that's just a straight forward linear force. Now, the motion it results over here would be this circular, and we put the Greek letter tau, right? And that tau is a vector as well, right? And that is the circular force, which we call torque. Now, the torque, which is the magnitude of torque, you heard of torque wrenches maybe, or maybe even have one if you deal with cars and stuff like that. How many foot-pounds or newton meters of torque you are going to put into a screw? If you turn the screw or a bolt too much, it will snap off. And that creates a whole new spiel of problems, because now you have to bore out the hole and get this old stuff out and get a new one in. So it's a lot of problems. So there are, for cars and other mechanical devices, there are specifications on how much you get to tighten each one of those bolts. The closest you guys get to this would probably be changing the wheel on your car. And you should have a torque wrench for something like that. If you tighten it too much, like if I step with my 270 pounds on the wrench, I might snap off the bolt off of the tire, right, of the car. So that's not good. But if it's too loose, you are driving a lot, hundreds of miles before you, or thousands of miles actually, before you rotate tires or something. The bolts just, if they are loose, they're just going to fall off, and the wheel is going to fall off, and that's not fun if you're driving 80. So there are specifications, and you should have a torque wrench, unless someone else is doing the work on your car all the time, to at least tighten your bolts on the car if you are changing your spares and stuff like that. So what's happening here is, so you can apply too much and you can break it. Now, the longer the handle, the easier it is to deal with all of this stuff, because the torque, and we have to put the magnitude there, because again, we are interested in the numbers only, is going to be given by the magnitude of R cross F, which is the force, and the vector R is the vector that you are, now this is R from the center of the bolt all the way out towards where the pressure is applied with the force. Maybe you heard of a concept of the breaker bar, maybe you didn't. Breaker bar is just an extension that you put on top of your wrench to give you the longer handle, right? Give me the lever long enough, I'll move the earth. So the idea is that further away you are from the ground zero, right, from the center of rotation over there, the easier it is to move this bolt. Which is the concept of the door. If you look at the door from the bird's perspective, you're flying over, here's the wall, and then here's the hinge. This is the door. This is top view, by the way. And then here's the other wall. Right, so this is top view. You have your handle opposite of where the hinge is, because you will apply the force to the handle, push it forward, right? And then times the radius of how long the door is will create the torque. Oh, here's the example. Look at that now. Boom. Easy. You saw that? So you have the force, and then the torque will swing open the door. Now, how many times, right, you pushed to the wrong spot? Or you went and you pushed the door when they have that long push bar in the middle, right? And in some cases, you push in the middle and the door doesn't open actually, right? And then you say, ah! And then it kind of opens like 4 inches. And then you do more, right, to try. But if you go and use the handle or further away, because some of those doors, you really don't know which way it opens, right? If it's a single door with that bar in the middle, like, which side do I push, right? Because if you push side by the handle, right, chances are you're not going to open the door at all. Because the value for that R is going to be so small, right? And then times your pathetic force you're pushing with, right? It's not going to swing open the door. So you want to be as far away as possible from the hinge. Also for bolts and screws, you want to be as far as possible from the center of the bolt. But now you will say, hold on, I'm using a screwdriver, and a screwdriver is directly above the screw. Well, yeah, which is why you want the screwdriver with a fat handle. You don't want your screwdriver to be thick as a pen, because if your screwdriver is this fat and then there is a center over here, right, then radius is this much. If it's as thin as the pen like this, then the radius is very small. They are both creating a torque. This one is creating much smaller torque because it's a skinnier handle to grab. So that's why when you're buying a screwdriver, get the one with the fat handle, because it's going to be easier to tighten and loosen screws. That's basic physics, right? Don't just get the one that looks cute. And there you go. The word problem will give you the radius, and the word problem will give you the force, and you stick them in a cross product, and you get the vector, and you take the magnitude of it, and that's your torque, right? So it's mainly to get the concept out of the way. And that's the story of the cross product. I'm just going to really quickly check if I missed out on anything, but tightening the bolt. Ooh, opening a laptop. That means like lifting the screen, right? So it says opening a force of 1.5 pounds is applied the direction perpendicular to the screen of the laptop at the distance 10 inches from the hinge of the screen. Right? How much torque is used? Like, do we even care? No! Everyone in this classroom is able to open the lid, right? Easy, right? You can demonstrate for everyone. So why do we bother this? You have to design it. Are you a mechanical engineer? Your job is to design this hinge, and this hinge needs to be good for 100,000. Open, close, open, close, open, close, open, close, open, right? So think about that. And when you are designing something like that, you want to know how thick is going, your hinge is going to need to be, and all that stuff to design these things. So it's not a question if you as a user can lift. You are not here in a user mode. You are here in design mode. You want to be mechanical engineers. You have to be able to do these calculations, because that is your job, to design something that will withstand 100,000 up and downs. And then it can break. But then by that time, it should be out of warranty, so you can buy another one, right? Like, it's all the precise timing, right? My laptop dies 3 days after the warranty expired. Company goes, perfect, right? Here's a new one. And if you're buying those stupid iPad, whatever the hell they're called. People say computers. They're not computers, garbage. Apple computers like $3,000, and they're like, yeah, bring it more in. So yeah, there's that. Bicycle brakes, electrons and particles in a particle accelerator. Ooh, here's some arm torque. A horizontally outstretched arm supports a weight of 20 pounds. Someone is working on biceps over here, right? There's one thing that you can do, right? And do some That would be like a cool thing when you go to the gym. I don't know if you go to the gym. I don't. Everything you pick up is heavy. It's disgusting. But maybe you go, right? You just approach the resident person. Do you know the torque in your elbow, right? And then you just go into the hole. It works best if you don't know the person. You know what you guarantee? Clear space to work out. Now that I think I should go, it will be a lot of fun. All right. Yeah, well, that's the Cross product. Bye.